All right, welcome back, everybody. We got two more lectures, this one and one on hyperbolas. Today we're looking at the ellipse. Now, I know you heard the word, even if you don't know its context, whether it was in a math course, you've heard of an elliptical machine, right? And like a gym, the path follows your feet on an elliptical machine follow the path of an ellipse. An ellipse in regular man's terms is an oval. So ellipses are like ovals. And just like we used the focus to help with the parabola, we are going to use two focuses. We will use two focus points. And when we call them plural, the plural of focus is a foci. That's the plural form of focus. Now on the parabola, we had the distance from the focus to the parabola was the same as the distance from the parabola to the directrix. There is a distance relationship with parabolas or ellipses to their foci as well. Let's just draw like the two standard ones. We could have one that's kind of flat, or we could have one that goes up and down. The foci are inside it, and they are near the end, closer to the ends. The closer to a circle this gets, the closer these foci are. Until they basically merge at a perfect circle. And they merge for a perfect circle. Now, the definition of the ellipse is definition, so we can get to that distance thing we were talking about. An ellipse is a set of all points in a plane where the sum of the distances to the foci is equal for all points. So graphically speaking, if I pick any point on the circle and I draw a line from the first focus and I draw a line to the second focus, and if I say this is D1 and I say this one is D2, D1 plus D2 equals a constant. I have seen these drawn by hand by putting two push pins into like cardboard or something like that, and having a string with the measured distance tied to each of those. And you just put a pencil on the string and you pull it out as far as you can from the 2 points. This is the string, put the pencil, and you just keep dragging the pencil where it's taut the whole way. When you get near the ends, it gets a little hard because like the push pin gets in the way, but you can kind of like fill in the gaps with your hand. It is doable by hand. We still use this point here in the center. Is going to be our HK on any form. The major axis. How do I want to describe this? Maybe I should draw another picture without all this writing on it. Does anyone need this up longer? I see some people writing. I'll pause for a second. They use this shit in like machines that crush kidney stones. In fact, we'll do an example later on with it. Just the same way the parabola reflects everything in one direction. When you start something, originate something at a focus, the ellipse does too. If you originate something at a focus in an ellipse, no matter where it goes, it hits the other focus. So what they do is they put the kidney stone, they have you situate yourself in like this ring where the kidney stone is at one of the focuses and the other focus generates the waves. And the waves pass through your body just fine because there's like hardly doing anything throughout the rest of your body. But right at the ellipse or right at that focal point where the kidney stone is, all of the rays are converging into like this crushing fucking sound wave. And it just polarizes it. It's kind of fucking neat, right? That's kind of neat. That's how they do it without invasive surgery. Good stuff. So if we have the ellipse going like this or like this, the major axis goes through the long one. Goes through the longest route. I want to say it's vertical or horizontal, but you could we're not going to do it in this class. If you go far enough in algebra, you can have ellipses that are rotated. In fact, I think you look at them in like linear algebra, how to generate an equation for a rotated diagonal ellipse. We're not going to do that in here. And if we go through the thinnest point, which is perpendicular to the major axis, this one is called the minor axis. The general form of the equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. So what is A and what is B? A is the distance from the center to the left side. That's A. I did it from the center. That's A. And I could do it here. No, still going that way. It goes A either direction. And guess where B is? Not necessarily on the minor axis, but the other axis. The B goes with Y. I want to say the book fucking teaches it with B being on the minor axis and the A being on the major axis. And that fucking changes this equation around and it gets fucking confusing because there's too many fucking variants. That's not important. The way the book does it is way fucking harder. Keep this consistent. Keep A with X. Keep B with Y. And just the way you tell which axis is major. If A squared is greater than B squared, A is the major axis. A is along the major axis, I should say. And if B squared is greater than A squared, B is along the major axis. Now, keeping it this way, different than the way the book does it, there is a change that we're gonna do later on, but it's to only one single fucking equation, and it's just fun. You keep this consistent, you keep it like this, it's easy to fucking remember. In fact, if this is kind of neat, if A equals B, let's call that R. This equation becomes x minus h squared over r squared plus y minus k squared over r squared equals 1. And if we clear fractions, x minus h squared plus y minus k squared equals r squared, which is what? It's a circle. So when the major axis and the minor, that makes sense that the distance along the two axes is the same distance. It's perfectly wrapped. And for both of these, this is a little bit different than the way the book does it. But I think it's easier to remember. We just keep it constant. We use the letter C for the focus. Foci use C. And C squared is the magnitude of A squared minus B squared, the absolute value. And C is, the foci are always on the major axis. You ready for a little bit more? Add some more with the focus on that. People are still writing. I see pencils moving. I'm fucking rushing this. I'm all fucking excited about this shit. Another major thing that is elliptical that most people don't think about. The orbit of planets around the sun is in an ellipse, where the sun is located at one of the foci. Out in fucking space. It's different for each planet. We don't all travel in the same fucking. All right. I see people start moving. Let's take this, let's go on a little bit further. Let's, for a little while, we're gonna set the vertex or center at 0, 0 for a little while, just to simplify the ideas that we're starting with, which just means h equals 0 and k equals 0. But the equation hasn't changed. That simplifies this down to x squared over a squared plus y squared over b squared equals 1. And if I have a squared, where a is greater than b, I have a flat ellipse because a is larger, so the major axis is along a. And the foci for this one are located at plus or minus c comma 0. Or generic HK. The foci are at H plus or minus C, comma K. So in this picture, this is actually A right here. This is negative A. This is B, and this is negative B. Since we're centered at the origin. With that in mind, how long is the major axis? It's 2a, right? We have a distance a here and a distance a there. And the minor axis is 2b. Now, when we switch to vertical, only a little bit changes. We will still cross at negative A, and the height of B and negative B. Foci are along this axis now. Still the same equation here, B is clearly bigger than A. And the foci are now at 0 plus or minus C. Or in general, HK plus or minus C. And now down here, our major axis is the other one. It's 2B. I don't think memorizing formulas for the major axis or minor axis is convenient or handy or anyway fucking useful. You can always just, if you sketch the ellipse, you can always just figure out what it is looking at it. It's not helpful. Where it does help is if that's one of your pieces of information and you need to draw the ellipse, knowing which way it is, if it's a flat one or a tall one, and how long the major axis is helps you out. But again, I don't need a formula for that. I know it goes half one way and half the other. So I just need to divide the major axis by 2 to figure out how far to go. There's one more thing we will do with C's, but we're not ready for that yet. We're going to do some more stuff first. Let's do some graphing. Anybody need this stuff out longer? So let's graph, find the domain, range, and foci of the following. Let's go with 4x squared plus 25y squared equals 100. First thing we want to do is write this in a usable form. I don't have an A here. I don't know what B is. And the problem is the right side doesn't equal 1. So how can I make the right side equal 1? I could subtract 99 over. Oh. That's not going to help me find A or B though. Is there another way to get it? We could divide by 100. Subtracting 99 would give me a 1, but that's not really our equation didn't have an extra value on the right. So dividing by 100 is the way to go here. And 100 is conveniently 25 times 4. So if I rewrite this, what's the denominator for the x squared term? 25. What's the denominator for the y squared term? 4. So now this is in the form that is usable. This is in x squared over a squared plus y squared over b squared equals 1. So what does that tell me about A and B? Let's go back a step. What does that tell me about a squared? If I want these two equations to look the same, what does a squared have to be? A has to be 5. A squared has to be 25. These two have to match up. And those two have to match up. A squared equals 25, so A equals 5. And B squared is 4, so B has to equal 2. I don't have an HK, so it's 0. It's the origin. B is the vertical amount. I know I got to go up and down 2. A is the left and right amount. I got to go left and right 5. Put some points there. And do your best to sketch an ellipse. Note when you are graphing, an ellipse is round. Do not put the 4 points and draw a fucking diamond. If you do this and you give me some shit like this on the exam, I'm gonna fucking mark you down for being a lazy fucker. Because that's all it is. You don't have to have, it doesn't have to be a perfect ellipse, but it does need to look round. It can't look like a diamond. It's the easiest thing on that. It's the easiest thing on this last exam. Just making sure that fucking thing is curved. And yet every semester, I have people that draw diamonds. I don't fucking get it. Like you don't, it doesn't have to be a perfect oval, but it should look round. None of my ovals never look great. This one's not bad, is it? It's not bad. It helps to try to, when you're doing it by hand, doing the hash marks, try to do the same distance. And try to keep it on the major axis semi-flat as you leave. Notice as I'm leaving the points along the major axis right here, it's sort of flat. Here it has, I don't even deal with that until I get to them. I start with the major axis and curve towards them. Now, if they're close to like one's 4 and one's 3, where it's like almost like a circle, it's not going to look as flat as this, where it's 5 and 2 and they're kind of far apart. But we can do it. Where are the foci?
C squared.
Minus b squared. We will do one that's plus. That's the hyperbola. That's next week. So in this case, I've got 25 minus 4 is 21. And I don't need the absolute value here. And that's c squared. So c is the square root of 21. Which is approximately like, I don't know, 4.6 maybe. I don't know, something like that. If I were to actually say it, I would say here, the foci are at plus or minus the square root of 21 comma 0. The only reason you would use this is for sketching purposes. Don't simplify the focus, leave it in the whole form. That just tells me that it's way over here and it's way over here. Ready for another one? Everybody good? I don't want to turn the page so y'all ready. Okay, no, it looks like you're ready for more. Now, what's the domain and range?
Domain would be -5 to positive 1 in the bracket. The range is -2.
Yep.
Is there an easier way to say that than the same use the bracket?
Not really. I mean, you could say domain is bracket 5 comma -5 end bracket. But
It's like I said, it was stupid.
nah, it doesn't get any better.
Okay, cool.
Now, if you weren't gonna say brackets, well, I mean, you kind of want to say brackets, because I wanted to see what you want. You had to tell me what to write. All right, let's put this next one up. 49x squared plus 9y squared equals 441. Follow what we did last time. At least until you get a sketch. So what's the first thing to do here?
I feel that's kind of
And what does that make my new equation?
X squared over 9 plus y squared.
What does it give me for A and B?
8.
All right, so. Did you guys graph it? Looks like it's tall, right? B goes with the Y, so I need to make this kind of tall. And not perfect, but it works. What's the domain here? And range? Clearly brackets, so I won't make you say them. Oh, here's a fun question. How long is the major axis? And minor axis? The major axis is 14. It's always along the long part of the ellipse, and we just, if you need to, count it. Usually, if you graphed it like this using A and B, just double the larger value. The larger value is 7, so 2 times 7 is 14. And we'll do the same thing for the minor axis, but the smaller value. Where are the foci?
Zero plus or minus the square root.
They are at 0 plus or minus the square root of 40. How did you get that?
I had c squared equals the absolute value of 9 minus 49. 40. And then you square root.
Square root of 36 is 6. Square root of 49 is 7. 40 is closer to 36 than it is to 49. So this is probably about, I don't know, 6.3, 6.4. Probably 6.35. What it, you got a calculator? What is
6.32.
6.32? Okay. So going along the major axis. I got too many steps. No, I did. It's going to keep it close to the 6 there, closer to the 6 than the 7. So that's a foci, and that's a foci down there. Here's a good time to bring in the next topic, eccentricity. Unfortunately, we use the letter E. Measures roundness. E is always C over the length of the major axis. So if this equaled 1, it would mean the major axis is also C. Which doesn't work. The foci is always inside the ellipse. So this is always for an ellipse. E is always less than 1, but greater than 0. This is not E like log E. Different kind of E. For a circle, it's 0. And for parabola, E equals 1. All right, so let's figure out what E is for the last one.
Square.
I did say length of major axis. Half of length of major axis. My bad. I did say that.
7.
Yes, so this ends up being, it's either E equals C over A or C over B. My bad. So bottom is 1/2 length of major axis. I changed the way I described it today, just now. And in my notes, I have C over A or C over B. And it was always pick whichever one is largest, but that's like confusing. And then I made it fucking confusing here. So yes, here we will have B is the larger one, so we will put that over 7. You got a calculator, what is that? Let's go 3 decimals.
0.90.
Okay.
But 0.90.
Oh, would it round it up?
Yeah.
Okay. Oh, yeah, that's a beauty. All right, you guys ready for another equation? Another problem? Slightly different than graphing? Nope, someone's still writing. I'm trying to rush the gun here. Oh, that's got some bite to it. Let's write the equation. For the ellipse. With foci at -5, 0, and 5, 0. And a major axis length 18 units. So with the information I have, what is some of this stuff telling me? With the foci at -50 and 50, what information does that give me? It's related to what we've been doing here.
If you just sort of look at it equal to the a squared minus b squared, absolute value of it.
Say that again?
If we were to plug that into the equation of then we have anything equal to the absolute value of a squared minus b squared,
If we squared it,
yeah, b squared.
which means this is C. These give us C. C has to equal 5. How long's what is major axis length of 18 telling me?
The. In this case, the A value would be. Nothing,
Why is it A and not B?
because the foci are on the x-axis, not the y.
Yes. So if we had a picture like this. And the foci are over here and over here, it tells us it's got to be going like this. Which means the major axis is the along X, which means it is A. How do we get B?
We plug those in
To what?
to the equation that gives the whole thing in the first place.
Yes. So 25 equals 81 minus b squared. I'm going to ignore the absolute values and I just know, in fact, when the absolute value, when it's the major axis is along X, the absolute values don't do anything. We do know that whatever it's going to be, B has got to be positive anyway. So if I do 25 minus 81, what do I get? $56, is it 56? So -56 equals negative b squared. So b squared is positive 56. Which means b is square root of 56. Which is right around approximately 7.5-ish, but we're going to leave it as square root of 56. It's got to be lower than that. No, not much lower. Maybe 7.4. So, damn, it was close to 6.5. Look at me, go days. All right, so what's my equation here? What's the general form without plugging anything in?
X squared over b squared.
And so what does that mean for this equation?
Square over one.
That's why we want to leave b as a square root. Because the square of that's really easy to fucking find. The square of that is a calculator thing. And you're probably, if you fucking round it anywhere, you're not gonna get back to 56. But the actual answer would be b squared is 56. We saw that right here. In fact, I even had it written down. B squared is 56. That was neat, right? Okay, if they have you only doing half of an ellipse. Is everyone done before I start moving? Okay. If I have y over 3 equals negative square root of 1 minus x squared over 4. You'd be like, what? Let's look at the graph, the domain, the range. I don't like the square root, so how do we deal with square roots? We could square it, and we're going to square it. So we're going to square it. And before I square it, though, squaring is going to destroy a key piece of information. The square is going to destroy that negative sign. So, starting here, we can see that no matter what's in this thing right here, the square, this has always got to be 0 or greater, the square root. Always we got complex numbers, which means I've got the negative of a positive number. Y is always negative. We got to remember that when we get to the end, when we're graphing. No positive Y. Now we square it. And what do I get?
Excellent.
Say it again. Do I want to leave it as y over 3 squared though? Let's rewrite that as y squared over 9 equals the 1 minus x squared over 4. And if I get everything on the same side, if I add x squared over 4 to both sides, I get x squared over 4 plus y squared over 9 equals 1. Which tells me this is the shape of an ellipse. But y has to be less than or equal to 0. All right, so what does my graph look like? What are my X values along it? How far do I go left or right? -2 and 2. What about Y? +3 is off the list. So just -3. Which means my ellipse is doing something like that. It's just half of ellipse. What's the domain here?
-2.
All right, you guys ready for some more fun? Yes.
Why is it just? Why it just didn't stop because of that negative and the
It stops because the original equation was y/3 = -√1 minus x²/4. By squaring it, we introduced new information, which makes it so we like this is actually, this would be the whole ellipse. But we didn't start with this. We started with this, and this restricted y to being negative. We see the same thing with square root graphs. When we have y equals the square root of x. If I square this, this is y² = x. And that right there is a full parabola sideways. We just got done doing that in 10.1. But the y = square root of x graph is only this part right here. Because I have the positive part here. And if I had said y = -square root of x, it would have been in the bottom half. All right, let's change this up. Let's go back to the full Monty, full glory of the original ellipse equation. Let's put the h and the k back in. Let's graph x. I wrote that kind of funny. X -3 squared over 36 plus y + 1 squared over 9 = 1. So we're going to graph that. We'll do the foci, domain, and range. Oh, fuck it. Let's find E. Let's do it all. So where is the center of my ellipse? The center of the ellipse is at 3, -1. That's good. That's That's some shit we need to know, right? What is A and B?
Is 6.
Yep. Does everyone see that? Just take the square root of 36, square root of 9. Okay, so with that, we can actually graph it. We got what we need to graph. We need to go to 3, we need our graph to include 3, -1. And we want to go, A is 6, so we want to go left or right 6. So it looks like I need to go really far to the right. My center is at 3, -1. And I'm just gonna put dots on my way to 6. I go right 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I go up or down 3. 1, 2, 3. And I go down 3. And I make a curve. All right, so how do I find the foci?
Yeah, value of 36 minus 36 squared.
It's already squared
Oh,
because you're squaring these.
36.
What is that? 27. So C equals square root of 27. Which is approximately, I don't know, 5.2. Maybe 5.3. Like a boss. Now, I'm not going to use the 5.2 to write my foci. My foci are at I know they go along the major axis, and it will help me put like dots for them. 5.2 is like way over here and way over there. My center was at 3, -1. That was my center. For the foci, I don't need to worry about the 5.2. I don't need to do no adding or no subtracting. All I got to do is say I know it's moving along the x-axis. So the foci are at 3 plus or minus the square root of 27, comma, the same k, -1. Now, if you wanted to graph those, you would need to put it in a calculator, convert to a decimal, and do what we did. But the accurate values for those foci is square root of 27, 3 plus or minus the square root of 27, and -1. What is my domain and range here? -3, +9. And the range? One way to find the domain is, the quick way of doing it is you're doing H plus or minus A. And the range is K plus or minus B. And that's how you get those values. I don't think that's worth memorizing. I think you need to look at the picture and go, where is it at? But it does help if you can see that. What's the eccentricity? So it's C over half the major axis. What is that here? What?
See.
And what's C?
Oh, sorry, square root of 27.
And what is that in a calculator? That's the correct, I would leave that as that, but it helps to kind of get a, see what it looks like.
0.66.
Yeah. Okay, so some fun things related to eccentricity. Earth's eccentricity. Earth's orbit, I should say. It has an E of approximately 0.017. Mars. E is approximately 0.0935. None of the planets have very big eccentricities. They go millions of miles from that fucking sun in their orbit, so you have a low one. But something that does have a high eccentricity is something that is not in our solar system for very long. Comet. Halley's Comet. Has an eccentricity of approximately 0.97. I don't know where its foci is. It's probably one of the black holes, one of the centers of one of the universes or the galaxies. Yeah.
You know how the Earth spin?
Yeah.
It's like kind of rests on perfect sphere.
Yeah, it's called an oblong sphere.
Could you measure that as?
Yes, it is a three-dimensional elliptical shape. Yes.
So we'd be able to find the eccentricity of the Earth itself.
If we pictured as something going around, yeah, we could find the curvature. We'd have to figure it out. It's probably close to zero. It's probably much closer to zero than Earth is close to zero. Because going around the Earth is, well, like if you go around the equator, it's round. If you're going around like the North Pole, it's like north to south pole, it's more elliptical. Which is neat. All right, so let's do one that is a planet I didn't mention. Let's take a look at Jupiter's. So Jupiter, like Earth, has an elliptical path with the sun at one foci focus. Eccentricity of Jupiter is 0.0489. And the maximum distance from the sun is 507.4 million miles. This is from the World Almanac. We are going to find the closest distance to the sun. That doesn't seem like a lot of information to go off, does it? So let's just draw a sketch without, like, no coordinate system or anything like that. We know it's following an elliptical path. And I'm going to put the sun at a foci here. I don't know how far in it is. I'm just going to say that's the sun. So in what direction is the maximum distance, the way I drew my ellipse? To the left, right? If I'd done it tall, it would have been up. But this distance right here is our max distance. That's our 507.4 miles. What distance are we trying to find? We're trying to find that one. That's the shortest distance. That's our goal. So if I kind of do that with a coordinate system, let's say the center is right here. That tells me, well, what is this distance right here? From the center to the left, in terms of a regular equation. Just A, right? Oh shit, I don't want to write center, because I want to write center, I don't want to write C. This distance here is what? The foci are always C away from the center. The foci are plus or minus C from center. And since the way I drew it with an A. I could have done it vertically and done B, but this tells me A plus C equals 507.4 million miles. I guess I could turn that into millions and get rid of the millions. that used this piece of information. We have one other piece of information. What can I do with that? What does E equal regularly, equation wise? And here my major axis is 2A, so this is C over A, right? Right, that's the major axis, so. Does that make sense? This is 1/2 the major axis, which is 2A. The way I drew it, if I had drawn it vertically, it would have been 2B, but it's not going to change what we do for our next part here. Well, I can use this and say I can clear the fraction and get 0.0489 A equals C. And now I have two equations and two unknowns. We have a system of equations. So rather than doing the addition method, I am just going to do substitution. I know this C matches this C, so I'm going to plug that in. That means I get A plus 0.0489 A equals 507,400,000. If I add these two A's together, what do I get? It's the coefficient. This is not a trick question if you're thinking I'm trying to trick you.
0.
Y times 2A. I'm just trying to put these two together. Yeah. We don't see the coefficient of 1, but it's there. So that makes finding A relatively straightforward. What is that? We'll round off the last 5 to zeros. Well, like to the 100,000s place, what is this?
So
Okay. So I'm gonna re-sketch my picture a little bit. Right here. That's my A, right? That's telling me the length from there to there. That's my A. My sun is right here, and that length is C. What does this length have to be in relation to this? I don't know what it is. I call it D, but doesn't it look like C plus D should equal A? Right? So D is going to be A minus C. And we have both of those. We have 483,000 million, sorry, 700. Well, I can calculate C, right? C is 0.04089 of A. Oh, we need C real quick. What is C? It should be a low number, like, I don't know, 20 million, 20, 25 million, 22 million.
23,600,000.
600,000. Which means that distance is 460,100,000 miles. Interesting, right? That's how they figured this shit out. Well, some of it, you figure some, I don't know how they fucking measured that distance. You know what I mean? How do you measure it? Fuck if I know.
Tape measure.
Right? That's a really fucking big tape measure,
Phase.
right? This is gonna take forever. All right, that machine that crushes kidney stones is called a lithotripter. Lithotripters crush kidney stones using shock waves. So they put a patient in an elliptical tub. They put the kidney stone at one focus. They put the wave source over here. So this is like F1 and F2. And fun, interesting fact with the ellipses is the reflective property inside of it. No matter which direction this emanates from the shock wave, because it's sending out a pulse in all directions. They all fucking converge on the kidney stones. So obviously how the size of the tub is going to change the position. So let's say the tub is based on x squared over 40 plus y squared over 24 equals 1. how far from the center of the tub should the kidney stone and wave source be placed? Wave source placed. Without all my refracting or reflecting beams in there. What is this question asking me?
Fine.
Not from the two foci, but close. It's finding the distance from the center to each foci. That's what we're trying to find, question mark. What is that on an ellipse if one of them is at a foci? C. Each one is C away from the center. So using the equation we have here, how far should we be placed apart? How do I find C?
Square. Two value A squared. Square.
Yep.
Sixty. Square root of 2. Square root.
So 4 units away. I think we've done enough damage for the day. You guys have a lot to think about. Enjoy. You guys have any questions? Try to work on this stuff. At least go through the homework and find all the ellipse problems. I hope they say ellipse before Tuesday, because Tuesday has, or next week, I'm going to point out what we're covering so that you don't start doing those yet. On Tuesday, we do hyperbolas. And the general form there is x minus h squared over a squared minus y minus k squared over b squared. And sometimes it's the other way around. Sometimes the y one. But one of them is being subtracted from the other. So when you see those, don't do those.
Is that going to be 10? Or is it-
Yes, that's 10.2. So the minus sign is what makes it. Makes it the hyperbola, not the ellipse. But some of the other stuff we do with like finding C and stuff are similar to this. So I'd rather have you have like get some work done on ellipses. So you've got some practice in there so that when you are doing hyperbola, you can see the difference and aren't going, which one is this? Like practice them and get the practice in down. Other than that, you were free to go.
If the homework for that one, did you have to do it the day before the test or did you do more time?
It's the, I said them all due the day of the test. I even think it's due at midnight. So like if you're a fool and you decide to wait till after you take the final to finish your homework, you can. I don't recommend that.
That's the 16th, right?
Yeah. So next Tuesday, we will do hyperbolas. Thursday, we will do a review exam, which means I better fucking make the review exam this weekend. It's fucking notes itself. And then Tuesday will be the exam, following Tuesday. We're almost done.
Inquiry about.
An inquiry.
Yeah.
Really? Are we fucking English now? What the fuck? Inquiries.
When I was